I understand that you guys have been doing a lot of different work with the suits and being able to have the people integrated into the vehicle. Can you tell us a little bit more about that and if there's been any problems with Atom Works being able to make the composite shell for the cockpit, and if there's been any problems there?
Very little. As the question about we have more than one suit vendor, and what their various issues are is proprietary to the vendor. So what I can say in suits is there's no major obstacles evident, but there's still work to do. Of course, we don't need the suits to start the flight test program. We just need them when we start breaking 50,000 feet. It is our plan to start the flight test program with helmets and oxygen masks rather than with the suits. To give you one example of a detail that has taken a lot of work and is not done yet with the suits, it's integrating all the penetrations that have to go on with a suit, like your umbilical hoses and your connection to the intercom. We also have to integrate that with a parachute harness, because you're wearing a parachute in case that you have to bail out, and with the seat harness that holds you in the vehicle under the various accelerations in the event of a crash. So there's an awful lot of straps that all have to go into the same place, and that all has to be planned out for the suit.
Now, with all the different work that you guys done, especially on the RCS thrusters, can you tell us a little bit about sort of the surprises that came across in both the efficiency and integration for your RCS thrusters? Okay,
RCS engines are surprisingly difficult. They don't get the respect that they should in a lot of people's vehicle development program. There's a temptation to think that the main propulsion is where all your attention needs to go, and the auxiliary propulsion or the steering is sort of a secondary matter. We'll leave it till later. But if you want to use non-toxic propellants, which we have to in order to get our operations cost, then there really isn't an off-the-shelf solution. The propellants have to be fed and delivered to the engine in zero gravity and in non-zero gravity that might point in a variable direction. And because they're distributed thrusters all over the vehicle that fire intermittently and in an unscheduled way, you can't count on the propellants always being at the same temperature or condition that they were when they left the tank. So we put a lot of work into that. It was one of the first things we started working on. We had a system based on nitrous oxide that was good enough to fly with, but we weren't very happy with for various technical reasons. We've now gone away from that, and we have developed a second generation system that we're a lot happier with. And that's sort of in the final tuning phases. It's ahead of where it needs to be because, again, we don't need that to start first flight.
Good, good. Now, you guys have been doing work for United Launch Alliance using liquid hydrogen, and do you plan to use those sort of fuels for future Lynx vehicles?
For future Lynx vehicles, no. The economics of hydrogen and suborbital flight don't really work together. Hydrogen itself isn't outrageously expensive, but it does take more care and feeding to deal with than some of the other more conventional propellants. The performance is higher, but we already have all the performance we need for a suborbital flight. We don't need more. For the orbital system, it was not something we had originally had any commitment to use, but it was something we had been looking at. And now that we have been getting experience with it and we're not afraid of it anymore, although we do respect it, it looks like a promising alternative for the second stage of the orbital system.
Well, Jeff, thank you very much for sitting down
My
with us.
pleasure.
We always appreciate it.
Very good.